So let me introduce myself. So I'm Yiannis. I live in Scotland. I'm a software engineer, and for the past more or less 30 years, what I've been doing on and off is asset tracking, and in particular vessel tracking in the North Sea. And that gave me an idea 5 years ago during the COVID pandemic. Can I bring this? Now I will start. Can I bring this? Try to share the screen. Sorry, it's coming. So the idea was, if I can bring this. Oh, come on now. Why? I've noticed that my browser is not working. It's working. So my idea was, can I bring this, which is marine traffic, as most of you know, into a Commodore machine? Can I track the vessels real time and see them? I always wanted to play with data coming, and back in 1987 when I got my Commodore, there was no internet and there was no data flow, so programs were pretty static. From the other hand side, I was also thinking that everybody's doing games. Let's try to make an application that can actually do something. So I spent 5 years learning machine language because I had never actually done anything on this. I was mostly a C# Java guy. And 5 years later, I managed to have this. So what is this? This is essentially the marine traffic running on a Commodore 128. And the technology behind it is actually homebrew. I mean, the code is actually on GitLab. So I found a SwiftLink library on the internet, load it low in memory where the VIC screen is, because in VDC you don't need it. Pumping the data through the NMI of the C128, filling a buffer with the data. Then the IRQ keeps on draining this buffer. The buffer is running a decoder, so I'm essentially fully decoding the message as it comes. These are not pre-decoded messages. This is actually the full thing. I'll show you exactly how it's done. And for every vessel that I managed to discover through the discovery, I put it in a registry. And you can see here, for example, that the codes, the color codes are correctly because they correspond to the type of the vessel. You can have up to 256 soft sprites here, and they're moving. I mean, this guy is moving out. If you are lucky, you will see him moving out of the port of Aberdeen. And green is, red is tags, very red is tankers, yellow are service speed crafts. This one, I don't know, we'll find out. Of course, the problem that I had when I started creating this one is that how you can actually show the data to the user in a friendly way. And then I bump across a project by Martin. He was supposed to be here, who kindly lent me his QR code libraries. So now, for example, you can go with your mouse to any vessel that you like. If you right click on the mouse, don't let me down. If you right click to the mouse, come on, right click to the mouse. Sorry, the mouse is not very cooperative. Here it is. If you right click on the mouse, it will go to the vessel registry, go and get the information about the vessel, and will produce the QR code. And if you have a mobile phone, you can actually scan the QR code, and you will see that it will get you to the marine traffic website with exactly the same information for the vessel. can leave it for a few minutes there for everybody who wants to play with it. So you can see what is the ID of the vessel. You can see the latitude, the longitude, the speed, the course, heading, name, call sign, destination, the IMO number. That type 99 is the one that gives the color to the vessel. This one doesn't have any code, it's a generic thing. And how deep in the sea it is hitting, 3.5 meters. So why would you like to do this one? Because you can. And because I wanted actually to create some kind of software for the Commodore 128 that looked a little bit more professional or something. Recently, I even managed to let me try to get there. Oh, recently, I managed to implement a file system on it. So now you can also get the actual data. As you can see here, I'm logging every single message that is coming back, about 540 kilobytes. And I can show you how the messages look like as they are coming raw from the transponder. So, got a very small presentation of how do I did it. Oh, run, please run. So, small presentation of how do I did it and what's the technology behind it. So I am using Basic 8. I don't know how many of you know it. Not for everything, just for the rendering, because it has all the VDC libraries and you can actually render things in the VDC, even in 3D. And I didn't have time to learn VDC. I wanted actually to focus on the machine language. So Basic 8, because it offers VDC. I said, as I said, my plan is I will use its features to turn it into a 3D application. So that means that even it will be slow, you will be able to be on a first person and move yourself in one of those vessels and see the rest around. I've got pretty a lot of, still resources to do this one. I also wanted to play around with the misunderstood wait command of the basic, because by using this one heavily, I've managed to make basic sleep most of the time doing nothing while the machine language is doing all the heavy lift of the decoding. And then what the machine language is doing finally is setting one of the flags to what the basic is waiting, and basic is just waking up to actually do one of those things. And one of the things that is mostly doing is that, great, you have a message, it jumps here, that's all the line of the code that is doing, and it goes essentially with a double buffering and goes and draws and redraws the vessels, and that's happening quite quickly. And that's why, for example, you can see here that, we've got about 49 vessels watching. I've gone up to 250, and they all can be moving, and they are all up to date. Actually, sometimes this one is much more up to date. Oops. Actually, this sometimes is much more up to date than this one, because he's receiving a lot of data from all over the world, and he's updating every, 5-10 minutes, while this one is actually quite snappy. You can see these things moving. The other interesting thing is that you see Commodore is starting at 1:00 a.m., but because the so-called AIS messages type 4, they carry the time, I synchronize the real-time clock of the Commodore once it comes, so you can see actually what is the exact time on the machine once the software starts. Currently I think this one is running since morning, and I have decoded about 70,000 messages, and it's counting. And There is a lot of memory still yet left to continue. And memory-wise, it's a little bit, it might be a little bit amateurish. That's how I have started it. So I've got this serial comms library in the low 400 because it needs to talk to the Swift registers. Then there are where the tape is, the IRQ and the NMI bridge is sitting. Also to be able actually to use the kernel if needed. The ring buffer of the Swift link is sitting there where usually the buffer of the serial port is sitting. And then higher up in bank 0 from, I've got at 7,000 the vessels, the registry with where I save everything in memory, and the code is between 8,000 and AA70, and then I've got a 0 page only for the decoder, and then the basic is from there on up. And looks like that it's working, and I'm quite happy for this. I don't know if you find it exciting, but I mean, my future plan is actually to turn this one into a flight radar because it's the same idea, the same kind of data. I mean, it's actually lighter in flight radar because things are not encoded, while this guy here has to decode things. And that's it. I don't know if you find it exciting, but I find it. Any questions?
Many thanks, Daniel. I think it's pretty much exciting, actually. Yeah, I met someone who was preparing something a bit similar with using weather forecast data, so mapping it. I don't know if there are questions from the attendees. Maybe I will start shooting one because I see. So now you're using Vice, but so are you using expansion RAM for that, or how would that work if you have, for example, because now you have 49 vessels there, but are you also buffering the whole information of each vessel? How would it work if you have
Well, I'll tell you, basic 8 needs the RAU extension just for the double buffering.
Okay.
Okay, but the software doesn't need double buffering. I can actually share the code here. So this is where everything is starting, and essentially, as I said, up in the 7,000 area, which is in bank 0, there, I've got the structure for the registry of the vessels. So up to 250 vessels, I've got 200 now. It's 15 bytes per descriptor, so that's well within bank 0. And then in bank 1, I save the actual positional information and all the things that are coming, and I'm updating them. I'm not keeping them forever. I'm just overwriting things. So actually, the stock Commodore 128 is more than enough to run it. The only reason that I'm using the expansion is because BASIC needs it in order to do the buffering of the screen and be able actually to switch between one and the other and give the illusion of the motion. Mm-hmm. Plus the ultimate cartridge, because I can save their things, well, not faster, but than actually trying to save in a disk. I was trying to show you this file. If can you see my Windows PC now?
Yeah, kind of. I don't know if that's the sun or
okay,
big
fine.
goal.
Well, yeah, so I can show you this one. That's okay. So if I take this one, copy. I mean, this is the file that I'm actually saving. This is the file that I'm saving, and this one is being saved real time also from the library. So it has the ability actually to save quite a lot. And you can see here as the raw data comes inside the computer and how they are encoded.
Okay.
This is actually the real data, and I capture them to the file on the computer. And it seems to be coping with no problem. I mean, ideally, I would like actually to try to do this one faster way. I don't know. Maybe I don't know if I'm actually talking using the correct idea. This is just kernel calls to the right and the setlfs kernel calls, but I think it might become faster if you do something like burst mode or something. I'm not really sure, but you know, I mean, it has been loading things happily all day long actually, and it has not missed a bit. And yeah, of course, the idea is that there are going to be 3 more files created. One is going to be the actual registry with the save data. So when you restart it, you can actually start from where you were.
Oh, nice.
I don't know if there are any questions or if you find it interesting, but
I find it interesting, definitely. Yeah. I don't know if there are other questions from the. I see an applause as a reaction. Any other questions?
I have one question.
sure.
So have you open sourced that, or have you planned for Commodore 64? I know that you're using probably, RGB graphic interface from Commodore 128, but this seems to be also feasible for Commodore 64.
It's not impossible, as I said, as long, I mean, I'll tell you what I was thinking, and that's what I'm trying to do the last few days. If I manage to even optimize even more the file libraries, and I manage actually to write faster to the disk drive, then your memory issues just goes out of the window. Because at present, as I told you, I'm only keeping 15 bytes times 200 in an area as a registry. And the good thing with the Commodore 128 is that I can actually have a pointer there to the bank one where all the other data are. But I don't need in this scenario any of those things. I mean, I can have the pointers to point to records in files, especially for the static data, which are the longest and they never change. You can save them on the hard disk. So you don't even need to keep them in another piece of memory. So I think it kind of going to be possible for C64, and I think of porting it. Maybe you might need some kind of RAM expansion unit to make some swapping in memory.
I think, just like at least today, most of the people supposed to have like a real memory expansion, today. So it's easy to program for it. So
yeah,
okay.
It's not. I don't think that's a problem. And also, I have tested the SwiftLink driver, and works fine with the C64. No problems. You can go up to 57,600. What is the thing, and it works fine. What I have ordered though, I have ordered a weak 64 now, because the idea is that weak 64 is this interface that goes to the user port, not to the expansion. No, sorry, to the expansion port, not where the old RS-232 was, and that's supposed to give you internet access through its own layer. So the idea is that in the next version, I will actually poke the marine traffic website and I will import the PNG, decode it, and you will see the picture of the vessel. Or if it is a marine, or if it's going to be a flight radar, I will poke flight radar and I will bring the PNG of the airplane and I will actually convert it to something. It's going to be slow, but for a small size picture, it worth to be done, and then you can decode it. Yeah, that's the idea. Are there any other in the pipeline for me? I was thinking. Yeah, as I said, yeah, implement. Yeah, use the weak, enable the 3D mode. Yes, because the basic 8 allows you to 3D, well, some kind of rudimentary 3D. I was thinking that the other thing is that you can actually move yourself as a first person in a 3D environment and stay here and see the rest of the vessels. I don't know how much motion I will achieve like this, but it will be possible to see. And yeah, I mean, port it in C64 is a good idea.
Very interesting. Then you have new projects to come and present.
Yes.
In a few months, right?
I think maybe the next one will be to try to do the pictures. Import the PNGs and show them. Saying this, I need to say a few thank you. Thank you to, Martin is not here. Martin Goodwell, who's got a YouTube channel, who actually did the QR code, and he kindly lent me the code to do this one. And Arthur, who actually wrote the CBM PRG studio and where I've done most of the work there. And that's all about me.
Great. Many thanks again, Yiannis. I don't see any more questions, so I will just stop the recording.
Thank you very much.